guys, it's Tori from Half Tutors here, and this is my first video. Today I'm going to be talking about the basics of organic chemistry, an introduction. Organic chemistry revolves around the studying of organic compounds. An organic compound is generally linked with a living thing. What I mean by this is that it could be part of a living thing's body, or it could be part of the urine of the living thing, for instance. An organic compound must contain carbon, and most often it also contains hydrogen, but hydrogen is not mandatory, unlike carbon. Organic compounds can come from inorganic compounds, for instance, urea from ammonium cyanate. Now it is important to note here that not all carbon-containing compounds are organic, ammonium cyanate being one of them. Ammonium cyanate has the molecular formula of NH4 OCN. We can see that it contains carbon here, but this is inorganic. Hydrocarbons. Hydrocarbons are the simplest type of organic compounds. Hydrocarbons are molecules that contain only carbon and hydrogen. This is one of the hydrocarbons, and today we're going to be learning how to name this hydrocarbon. Before that, we have to preface this by explaining the relationship between hydrocarbons. Here we see a tree that shows all the types of hydrocarbons classified. Today we're going to be focusing on the type of hydrocarbons called alkanes. So what are alkanes? Alkanes are hydrocarbons with a molecular formula of CnH2n+2. So what this means is that, let's use an example. For instance, when n equals to 1, the number of carbon is 1, of course, so C, and the number of hydrogen is 2 times that plus 2. This would mean 4 hydrogen atoms. So basically, this is just a relationship between the number of carbons and the number of hydrogen atoms. So, from these examples illustrated below, we can see that alkanes are non-polar since they are symmetrical. Symmetrical here. That means that they have weak intermolecular forces, since strong intermolecular forces such as dipole-dipole require polar molecules. Most importantly, for alkanes, there are only single bonds between carbon atoms. Thus, they can also be known as saturated hydrocarbons. A saturated hydrocarbon has the property of only single bonds between carbon atoms. For instance, if there are double bonds between carbon atoms, these molecules would be known as unsaturated hydrocarbons. Now, a basic property of alkanes is that the longer or larger the chain of carbon atoms, the higher the boiling point. This is because the number of atoms increase, meaning that the London dispersion forces between the molecules increase, increasing the boiling point. So based off the formula we learned previously of CnH2n+2, let's classify these as alkanes or not alkanes. So we see here that the number of carbons is 3. So let's take this and plug it into the number of hydrogen atoms. So 2 times 3 plus 2. We get 8. And this is the same as the amount of hydrogens. So this is an alkane. Similarly, let's do it for number 2. 2 times 4 plus 2, which equals 10. It matches with the number of hydrogen atoms. So check, this is also an alkane. Here, let's continue on. So, we're expecting 6 hydrogen atoms, but this compound only has 4. So this is not an alkane. Let's continue on. So we're expecting 12 hydrogen atoms from a compound with 5 carbon atoms. But this one only has 10, so this is not an alkane. So naming alkanes. So we're going to be talking about the basics of naming alkanes. These alkanes are what we call straight alkanes. So that means that they are alkanes that exist in one continuous chain. What I mean by a chain is that all the carbons are interconnected with no carbon that's connected to more than 2 other carbons. So what I mean by this is one chain of carbons. Notice that I didn't draw the hydrogen atoms, but they are there. I'm just doing this for simplicity's sake. However, once I add 1 carbon over here, we can see that this is no longer a complete chain anymore. We can classify this part as a chain. We can classify this whole thing as a chain. We can classify this part as a chain. There are different chains here, and this is not a straight alkane anymore. For the straight alkanes, let's look at their chemical formulas. So for first one, methane, let's apply the formula again. CnH2n plus 2. So we have the number of carbons, so we need to find the number of hydrogen atoms. So 2n plus 2, so 2 times 1 plus 2. That equals to 4. So we know that the chemical formula of methane is CH4. Similarly, we can do the same for ethane, and we can come up with the chemical formula of C2H6, etc., etc. If you guys want to continue numbering them, you can. But I'm going to skip that. So there's a short acronym for remembering the first 4 straight alkanes. And this acronym is monkeys eat purple bananas. And we can see that monkey stands for M for methane, E for ethane, P for propane, and B for butane. Let's continue on. So some bit of practice naming the basic straight alkanes. So C2H6. So what is this? Let's check. We know that C2H6 has 2 carbons, and we know that the straight alkane with 2 carbons is called ethane. Let's move on to the second one. Now we see that this has 4 carbons, so we know that the one with 4 carbons is called butane. But nope, this is not it, because we know that the number of hydrogen atoms does not fit the formula, because the number of hydrogen atoms we're expecting is 2 times 4 plus 2, which is 10, not 8. So this is not actually an alkane, so we can't name it as butane. Let's continue on. CH3CH3. What is this? You guys may often have not come up with this structure, because you would think that you would group the number of carbons, right? But actually, you guys have encountered it probably in the form of acetic acid. Acetate can often be wrote as CH3COO. I put the H here for acetic acid, but acetate is this part, CH3COO. And oftentimes, you may have wondered, why not group the carbons and group the oxygens? Well, they write it like this for ease of identifying the structure in a Lewis structure. This helps them draw Lewis structures and line diagrams, which I will explain in later videos. But what's important here is that this is another way of writing it, and this is easy to draw Lewis structures. So this is a Lewis structure of ethane. And we can see here that this kind of naming allows us to know the number of hydrogens per carbon atom. And that's why people like this kind of naming. But anyways, based off the number of carbon atoms, it's an ethane. Let's continue on. This is written in a similar notation to the third one. And we can see that there are 3 carbon atoms. Let's count the number of hydrogens just to make sure it follows the formula. So we have 8 hydrogens. So 2 times 3 plus 2. Yup, that equals to 8. So what is the name of the straight alkane with 3 carbons? Well, that's called a propane. P-R-O-P-A-N-E. So let's continue on to the 5th one, the last one. So this is a straight alkane that's drawn as a Lewis structure. But we can name it similar to the previous ones. We just need to count the number of carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If you need to refer back to the previous slide with the names, you can. But this is called a non-name. That's all for today. Thank you for listening, and I hope you've learned something. If you guys are interested in more organic content, let us know in the comments. And if you guys have any questions, also let us know in the comments. Or if you guys don't understand a question from school, you guys can let us know, and we'll try our best to answer it in the comments or make a video about it. And most importantly, stay safe in these precarious times.